So learning target 5, we're using sum and difference identities. So in the first half, you're given some angle measure that wasn't on the unit circle, and you're adding or subtracting to get to that. In this case, we're getting given different information, but we're still accomplishing the same things. Okay? So it says to find the exact value, and it tells you that x is between 0 and pi over 2, and y is between 0 and pi over 2. That's just telling you that the two angle measures, because we don't know the angle measures this time, they are positive, right? That's the first quadrant from 0 to pi over 2, right? Yeah? Okay. So it tells us we're going to find sine of x minus y. Well, we have an identity for that. It's up here. If we're using sine of x minus y, that means we're using the signs at the bottom, right? Because we're using sine of x minus y, so we have to use the negative at the bottom of the other one too. If you look at this, I'm going to change these to x and y's so that no one gets super confused because it has x and y in the problem. We need a sine x, a cosine y, a cosine x, and a sine y. We're only given two of those things. We're given sine x and sine y. We do not have cosine x and cosine y. Everyone clear on that? Okay. So think back to learning target 2. How can we find cosine x and cosine y if we have sine x and sine y? I already have the identity. I'm saying I have sine x and sine y. How do I find cosine x and cosine y? We don't have an angle measure. It is based on one of the identities you're supposed to know. Learning target 2. What do you do if you're given something and you're trying to find something else? So we need to use sine squared plus cosine squared. We have no other option. We have to find cosine for these two. So sine squared x plus cosine squared x equals 1, right? Well, I know what sine x is, so I have 4/9 squared plus cosine squared x equals 1. Because I know what sine x is, so I replaced it. Four ninths squared is 16 over 81. And then 1 is 81 over 81, so when I subtract 16 over 81 from each side, I already have a common denominator. I changed 1 to 81 over 81, so I can have a common denominator. So 81 minus 16, 65 over 81. Question so far. This is something we didn't learn in target 2, so this is not new. So we take the square root. So cosine x is the square root of 65 over 9. And we're going to leave it that way. We can't do anything else. All right, so now I have sine x and I have cosine x. I have sine y. I still need cosine y. So I do this one more time, but with y's. So do this one more time with sine y. Sine y is 1/4. I'm just changing the variable. 1/4 squared is 1 over 16. So this one would be 16 over 16. So when I subtract, I have a common denominator. So I get 15 over 16. So cosine y is the square root of 15 over 4. keep in mind the purpose of me doing this. I have to use this identity, sine x minus y. I needed all four of those things. So I still haven't found what they asked me to find. They asked me to find sine of x minus y. So I found all the pieces that I need in order to find it, but I have not actually found it yet. So any questions about why I did any of these steps?
So once you get those cosine, or once you get the ones you don't have, that's it. No.
Once we get the ones that we need, we just have to go back and substitute them into the identity. So the last part's really short. So the identity, I'm going to do that to the side so we can see all the work together. If you want to do it underneath or whatever, that's fine on your note sheet. But our identity says sine x, or the quantity x minus y, equals. Do I need to write out the identity, or can I just fill it in? Okay, so it says sine of x is 4/9, times cosine y is the square root of 15 over 4, minus cosine x, which was the square root of 65 over 9, times sine y, which was 1/4. So I'm just following that identity. I just substitute the pieces in. I'm just following this identity up here. It says sine x times cosine y minus cosine x times sine y. It's on the front of your note sheet. So then the last thing you do is just multiply and simplify. It's fine. So you're going to multiply straight across. 4 times the square root of 15 over 4, 9 times 4 is 36. And then the square root of 65 times 1 is the square root of 65, and 9 times 4 is also 36. And then we just put them together. So 4 square roots of 15 minus the square root of 65 over 36. And that's our exact answer. You cannot subtract numbers from the square root. You can multiply them, but you can't subtract them.
Can we not do
Right. So, all right, so while people are still writing, I'm going to go back over the summary of this problem. Ready? They're asking us to find what's highlighted in the red box, sine of x minus y. We don't know those two angle measures. X could be whatever angle it wants to be. They're giving us the sine and cosine values, though. So they told me sine x is 4/9. They told me sine y is 1/4. But according to this identity up here at the top, I need sine x, cosine y, cosine x, and sine y. So all I had at the beginning was the two sine values. So I had to go back and find the cosine values. So I used what I knew from learning target 2. And I had sine squared plus cosine squared equals 1. And I found the cosine of x and the cosine of y. Right? Then I have all four. So I have sine x, sine y, cosine x, cosine y. And so then I replaced those values in the identity and just simplified. If I was given sine and I was trying to find cosine, yes, I would use sine squared plus cosine squared equals 1. Or if you were getting cosine and trying to find sine. We're going to get there in a second. Other questions? You can't reduce that, no. Because the other one isn't going to be divisible by 4. So if you divide by 4, you're going to have two separate fractions again. Again, if you divide it by 4, you'd have two separate fractions. You don't want to do that. Yes. Any other questions on this one? I understand I did not put a lot of space on the note sheet, and I've made a note already for next year that I need to make a lot more space. So if you want to get a different sheet of paper out to the next one, or if you just want to watch the next one so you can watch the video, it's about the same amount of work. It's not longer, it's just about the same amount of work. Okay, can I erase this? It doesn't actually get harder, it's just the same amount of work. Alright, on the second one, we're asked to find tangent of x plus y. They tell me cosecant x and cosine y. Now, go up to your identity because you need to know what you're talking about first. In your identity, it says for tangent of x plus y, I need tangent x plus tangent y over 1 minus tangent x times tangent y. So I need tangent x and tangent y to do this problem. Is everyone in agreement about that? Okay, now, there's two different things going on. So first one, I've got cosecant x. Cosecant is not related to tangent in any identity. Cotangent is, all right? So you've got two different options here. Two different options. One option, use sine squared plus cosine squared equals 1. Change cosecant x to sine x and use that to find cosine, and then do sine divided by cosine at the end to get tangent x. Or do 1 plus cotangent squared equals cosecant squared, and then at the end just take the reciprocal to get what tangent is. Either of those work. Same thing on the cosine part when we're doing y. We can find sine y and do sine divided by cosine to get tangent. Or there's an identity that says tangent squared plus 1 equals secant squared. I can make cosine into secant, and so I could figure out tangent that way. So you just need to tell me which way you want to do it, because I don't really care. Hey! So I'm going to use cotangent squared x plus 1 equals cosecant squared x. So I can find tangent x. I'm trying to find tangent x. I know there's not a tangent in here right now, but there's a cotangent, and I can switch that at the end. So I'm going to solve this. Cotangent squared x plus 1 equals 5 over 3 squared. And 5 over 3 squared is 25 over 9. I'm going to subtract 1, but that 1 is really going to be a 9 over 9. So cotangent squared x equals 16 over 9. Take the square root. Cotangent x equals 4 over 3 then. So then tangent x is 3 over 4. All right, so I have tangent x now. That's one of the things we need. We also need tangent y. I'm going to try to cram it in over here at the side. We'll see what happens. So I know tangent squared y plus 1 equals secant squared y. How can I make cosine y into secant y? Just flip it over. So secant y is just 13 over 5. So tangent squared y plus 1
So that's a property.
Equals 13 over 5 squared. So tangent squared y plus 1 equals 169 over 25. I'm trying to find tangent y. So I'm going to subtract 1. That 1 is going to be a 25 over 25. So tangent squared y equals 144 over 25. 144 over 25. Right here? It's just secant. 13 over 5 is what's in the parentheses. So I've squared 13 over 5. I've subtracted 1. And so far I've got tangent squared y equals 144 over 25. So you take the square root, and tangent y equals 12 over 5.
something equals that, like itself times itself equals 144, that gives square root. Like 12 times 12 is 144. 5 times 5 is 25. Is that how they are? Because see, I remember last year you had to, like, you get 4 thirds of 3 or something, or something like that.
These just happen to be perfect squares. On the last one we had square root of 15. So I found tangent x and tangent y because that's what I need in my identity. Is everyone good with that? So now we're just going to use the identity. It says we're doing the sum, so it's the positives are on top. We're using then all the signs at the top. So again, I'm not going to rewrite the identity, but I'm going to just simplify everything. So I've got tangent of x plus y equals tangent x, which is 3/4, plus tangent y, which is 12/5, over 1 minus tangent x is 3/4 times tangent y 12/5. Why do I do what?
Does it matter, plus or minus? Or,
Yes. Since I'm doing the plus sign that's on the top, I use all the signs on the top.
but if you did minus,
It told me to do tangent of x plus y. What's the bottom number where? 1 minus 3/4 times 12/5. That's 1 minus tangent of x times tangent y, like the identity says. I'm following the identity. Okay, I'm just going to simplify then. No, you do not remember these identities. 3/4 plus 12/5, I need a common denominator, which is going to be 20. It's going to multiply 3/4 by 5 and 12/5 by 4. So the numbers in purple are just the same fraction, just common denominator. So what is 15 plus 48? 63 over 20. That's the numerator. We're going to wait till the end. And then the denominator, we have 1 minus, you multiply straight across, so 36 over 20. So we'll change that 1 to a 20 over 20. And then you can do all this calculation stuff with the fractions if you're not comfortable with fractions in your calculator. So 63 over 20 over negative 16 over 20. And so I just multiply by the reciprocal. So 63 over negative 16 would be your answer. Someone asked me earlier, I remember I said that x and y are positive according to the directions. So someone said, well, doesn't tangent then have to be positive? Remember that x and y are angle measures, right? So they're not these angles. But what if x was 60 and y was 35? What's 60 plus 35? 95, which is in the second quadrant where tangent is negative, okay? So it doesn't matter what the angles, what those x and y are. They're just telling us that when we're doing all of this stuff over here to find tangent and tangent y, that we don't have to worry about the signs. That's all the directions are telling you.